So as you know, here at the Innovation Stage, we are going to talk about innovation with a strong focus on artificial intelligence. And we have a very interesting series every day around 2 p.m. where we go deeper into production. It's called Perspectives of Production, or shorter, the so-called Pop Talks. And today we are going to talk about some of the hottest topics here on EMO, I think, AI-enabled robots for machine tools. And in this session, we will combine technical insight with real-world examples. So we're not talking about what might be feasible, we show what is feasible. And it's definitely part of the EMO Focus theme, made for AI and digitalization. And I am super delighted to welcome Dr. Rainer Bischoff, who's General Manager Germany at Intrinsic AI, here on stage. He will guide us with a keynote into the topic, and then I have the fantastic task to squeeze him afterwards, whether this is feasible or not. Rainer, I hand over to you right away. Enjoy.
Thank you, Sven. I'm super happy to be back in Hannover. Hannover actually is my alma mater, so I studied electrical engineering here in Hannover, so I'm super glad to be back. And I welcome you to my presentation, Automating Machine Tools with AI-Enabled Robots. So I'm the General Manager of Intrinsic Germany. We are a wholly owned subsidiary of Alphabet, meaning a Google sister company. And our company is providing AI, providing tools, providing an SDK, providing a platform for the machine builders to make it easier for them to build automation systems for instance, CNC machines. Why we believe this is a good way to go for our company as an initial go-to-market proposition. It's actually about the market opportunity in CNC. When you look at the figures here, you see there's about 25,000 robots per year which are shipped for automating CNC machines. Of course, China is by far leading. The rest of APAC, about 4,000, EU, about 4,500 robots, and North America, only 1,000 robots. So these areas in the world are already lagging behind the Chinese adoption of robotics for CNC machine tool automation. On this chart, you can see what percentage of CNC machines today is actually automated. And it's surprisingly low. Also, maybe looking at the US, for instance, it's only about 2%, 3% of all CNC machines shipped in the US are automated. So huge potential. Also in Germany, only 10%. And if you look around here at the fair, you see so many machine tools already automated, or at least with an approach to automation. And this is something where we still can gain a lot with automating more of these machine tools. And this is something where we would like to help. But first of all, maybe look into the reasons why actually this is not happening today. So as you all know, robots are really fantastic productivity tools, but when it comes to employing them for automating, we have at least 4 problems. One of the problems is that you have a lack of agility in your production, meaning you want to produce another product tomorrow, you then have again some complicated configuration of that new task that you want to automate, or you want to change the parts that the robot is grasping. That's something that needs to be tackled. The second thing is the user skill gap. So the people that are programming robots today or that are operating robots today, they don't have the required skills to do more complex tasks, so you want to simplify that. The robot itself today is stiff, dumb, and numb, so it cannot feel, it cannot see, it cannot touch things appropriately. So there's a lack of capability in order to make automation more simple. And then if you want to combine all these technologies, you have a hard time to do that. There's a long time to productive use before you can actually enable these robots to see, to perceive, and to feel. Intrinsic's mission is to democratize access to robotics. What does it mean to democratize access to robotics? It's basically about simplifying the use, the configuration, the programming of robot systems for automation tasks. And to do that, we are building an AI-integrated platform. And what an AI-integrated platform is of the type that we are building, I will explain you in a second. First of all, one more word of who we are so that it's really clear. So we are an Alphabet company. We are a sister to Google, a sister to Waymo. And like Waymo, we are another bet of Alphabet. So Alphabet is betting on us that we can bring AI to the production floor. We can work with with some departments of Alphabet very easily, so we can easily tap into the pool of information that we get from DeepMind or from research. We can also work with the Google Cloud colleagues or the ones that are building Android. And with all of that, I would also claim that we have very good AI or talented people on AI technology. And this technology we try to bring now with our platform to the shop floor. We have a growing ecosystem of companies with whom we are working with. So there's a couple of robot manufacturers to which we are compatible with our platform. There's a couple of companies in the OT field. There's also a couple of companies that are already using our system. The most prominent one, maybe also relevant to this exhibition here, is Trumpf. And I will have an example to that later. We are also participating in an ecosystem project called ROCKS. So in the end, everything is about collaborating, and our platform is enabling the collaboration of various players in the value chain. The solution builder with the asset builder, with the system integrator, system installer, and the end customer. So all these companies in the value chain we are supporting in collaboration. I talked about platforms, but actually what is a platform in our sense? So our platform, first of all, provides an infrastructure. This infrastructure is here to allow you to have development tools from the cloud to the edge and also to real-time control. And this infrastructure is also there to enable you remote access to your robots. It's also there to update or upgrade your system in the field. So it's not just deploy once and run forever. It's a system that can be updated daily if needed. It's also about capabilities. So the platform is there to provide capabilities. Capabilities like collision-free path planning, like perception, or like force control-based insertion of objects for assembly tasks. It's also providing a set of tools. Tools for the solution builders to use the platform. Tools for the solution builders to build a product based on the platform. But also tools to create an HMI more simpler for the operator later on. And it's also about the ecosystem that we are going to create. So we are trying to address many, many more roles in that ecosystem, from a software developer to a hardware developer, automation engineers, roboticists. So all of them should it be much more simpler for them to build in the end a smart machine tool automation, which is sensor-driven, which is AI-enabled, a product that can be reused, it can be reconfigured, and in the end, of course, it should be scalable. Scalable is also always meaning it has to be updatable, it has to be flexible. You probably all know about the Gartner hype cycle. And this is more now a general introduction of where we are with certain types of AI technology in the Gartner hype cycle. So when you see here rule-based AI, this is, for instance, something that we do since many years, collision-free path planning. This can be done already today, so there's already some productive systems available. Deep learning is also reaching a maturity level where you can really say, okay, with deep learning, I'm able to perceive objects. I can reliably do pose estimation, just providing a CAD model, for instance. Reinforcement learning is something that we use to let the robot learn how to insert objects. So to use a very close sensor actuation loop in order to learn how to place an object into a vise, for instance. And then also large language models, that's the most hyped topic at the moment. But of course, it can be used to improve the way on how you're programming your system. Pretty much all know about ChatGPT, and just by prompting ChatGPT or just prompting a large language model, you can probably already design today robot programs for your automation problem. And then there's one thing that really is now creating a breakthrough in using AI and robotics. This is about foundation models that enable you to perceive objects without any new training required. And our task is somehow to pull these technologies further to the front, so to flatten the curve of that hype cycle. And how we believe this is happening, there's first of all a huge industry demand for these technologies. So this will push the technology more to the productive use. It's also possible to use a great amount of synthetic data now for deep learning. approaches. So you do not require to use only real data. You can do a lot of synthetic data. And of course, there's a couple of AI platforms. Ours not the only one, of course. And with these AI platforms, it's also possible to bring the AI faster to productive use. So this means that AI will create net new value across the whole solution lifecycle. And when I talk about solution lifecycle, what do I mean? It's first of all, it's pre-commissioning the development phase of a solution, and then it's also post-commissioning the operation phase. So in these two phases, actually, there can be a support by AI technology. During the development phase, you can, of course, benefit from the AI technologies I just mentioned in perception and path planning, because it's getting much faster to program your robot system. You don't really program the axis anymore. You just let the system do its thing. And then during the operation phase, you can also easily upload or upgrade the AI technology that is already existing in that solution lifecycle. And actually, when you look at this is more like a DevOps type of operation, so where you continuously update your system and benefit from new features, for instance. So how does it look like? In our case, we have a web-based development environment, so you can use like a tablet or a laptop, anything to develop a solution. We also provide a low-code environment, but if you do not want to use low-code, you can also program in C++ or in Python, text-based, like you always wanted to do it. When we talk about first-party AI capabilities, this is the ones that we are providing, but there's also AI capabilities by third parties. The whole thing about the platform is that more companies, more partners are able to contribute to a growing ecosystem. So there's also ways to address third-party capabilities. And also, the platform and the models that we are offering can be exchanged. So when we talk about artificial specialized intelligence, ASI or AGI, there's so much work going on in the ecosystem right now that we do not even know today what kind of models will prevail in the future. So our platform is agnostic with respect to these models. You can use the models that you prefer. And then you can go from a simulation to the real world with one click of a button. So on the right top, in the top corner, you can see you can just simply switch between simulation and the real world. The digital twin that is provided here is the exact replica of the real world, which means that the robot is moving the way that we want it to move because of our collision-free path planning. And then I mentioned already it's cloud-based and remote managed services. Because we have cloud access, it's possible to actually really go in deep collaboration with other companies on one solution, or you can access the system anywhere in the world, provided there's an internet access. So talking about the AI capabilities, these are the four most important or highly in-demand capabilities that we are offering. It's about perceiving objects. The camera can be at the flange of the robot system, or it can be statically installed anywhere in a robot cell. And based on this camera, we can identify raw stock. It doesn't have to be placed in a grid anymore. You can basically place it anywhere on a flat surface. And there will be also the ability to put it in a bin and then grasp it from a bin. The second capability is automated grasp planning. So it's not enough to just identify the objects. You also have to compute where I can actually pick it, so that this also does not have to be programmed anymore. So automatic grasp planning. And the third capability that's important is sensor-guided skills, for instance, for force-guided insertion. If you do not want to specify the exact position, but you know that you have to slide your workpiece into one area of the vise, you can do this with a force torque control at the flange of the robot. And once again, this is all robot agnostic. You don't need any special type of robot. You can use any industrial robot, any force torque sensor, any camera. You're not bound to a robot manufacturer's ecosystem. And for the most important part probably is the automated motion planning. With this motion planning, you are actually really able to freely configure your system. No one needs to program the robot anymore. It is programmed by itself or autonomously. One example from one of the automation leaders we are working with, this is Trumpf. Trumpf was exhibiting the system at the Euroblech in 2024. What you see here in the picture that is fast changing here, this is the image processing that we are using here. This is sheet metal that has been cut, that comes out of the cutting machine, and then when it's coming out, it is never really positioned in a way when it was cut. So you don't know the position of these parts. It's also not possible to train these parts beforehand because there's only short time from the production or when you know what has to be cut actually to the picking of that part. And in the top section you see what happens to the parts that have been identified after it comes out of the sorting machine. These parts are then stored automatically on pallets where you want to have them. There's no way that you can program this by hand or manually today. This is something that is really requiring automated path planning, perception, the way with our foundation models, how we are envisioning it. And then maybe one other example to really make that point on the foundation models. Today it's possible to have a so-called foundation model for industrial or for parts that are used in production, and you can just prompt the foundation model with the cut model of that workpiece that you want to manipulate, and after that you can identify the parts in the image. This works with a simple 2D camera, so you do not need a 3D camera. You can use multiple 2D cameras if you want to have a higher reliability, but as a matter of fact, this is something that is really revolutionizing the perception and the way we can actually program robots eventually. This works very well with sheet metal, but it also works well with more 3D complex parts. And once again, you do not have to train this anymore. You just need a CAD model of the part you want to manipulate and prompt the foundation model, and it will give you the 60 pose of the object. Okay, to come to a conclusion, what we see here is that AI today can really unlock value for solution builders, for solution users, so for the end customer. And what in detail this means is that by using a kind of software-based approach, you can much more easily develop a product. You can develop an automation product. It enables productization of your work cells. This creates immediate customer value, and the time to impact, because you only have to reconfigure systems, is much, much shorter. For the end customer, they don't need any expertise anymore in robotics because via an HMI, the user can actually much, much more simpler use the system, and that leads also to a high mix, low volume production. Yes, and then for both parties in the end, because it's a cloud and edge-based system, it can run without the internet access, but the internet access actually enables it that you can remotely monitor, you can remotely access it, and it keeps the AI technology that you have at a current level. So the updatability of that system means that your system remains current to the current technology. You're not just shipping it, and for the next 10 years nothing changes. Usually in robotics we say, never change a running system, but we want to change that paradigm. We want to say, always change a running system to keep it updated with the latest state of the art, especially now with AI. Yes, remote services and support, I addressed that already. Yeah, that brings me to the end of the initial part of this presentation and the talk that we are going to have. Thank you very much for your attention.
Applause, ladies and gentlemen. Rainer, thank you so much already. Please have a seat. If you don't mind, let's step directly into it. For you as an audience, very important, you're always able to ask questions via Slido. You will find the QR codes everywhere here on stage, so please feel free and don't hesitate to ask any question. I have a few, so I'm not getting into a lack of question. That's pretty sure. I like it very much. You know,
thank you, Sven.
Rainer, let me start with one question that probably has nothing to do with the topic itself. Yeah, it has, but more on a scale base. You, at the very beginning, you presented how far China is already in that topic. But then if I looked at the very right, there was a European...
Belgium.
Yeah, that was really... I stuck at that slide. I was like thinking 10 minutes, how could Belgium be so far ahead? So what is happening in Belgium?
I have one hunch, I don't know. So this is statistics.
Is your headquarters in Belgium?
No, this is statistics from the International Federation of Robotics. And of course, in Belgium, there's a company called RoboJob. So maybe they are actually helping these companies to automate their systems much more easily.
Okay, cool. So, yeah, why is it that only 10% are automated? Because there was no solution in the past?
I think one of the key problems is that robots are really complex tools. So they are great productivity tools, but they are too complex to use, to configure, to program. And I think we have to come to a stage where we do not have to program the robots anymore, but just provide a task description. And once we have come to that stage, then robots will be more adopted. I think it's simply because it's still too complicated to use these robots.
So I've seen you work with so many partners already. So the major partners of robotics are in there. So I start to think it in a very practical way. I do already have robots. Are they upgradable with your system?
Yes,
how does that work?
Every robot manufacturer today is actually offering a kind of software interface to their robots. At ABB, it's called EGM. At UR, it's called RTDE. At KUKA, it's called RSI. So these are interfaces that are used to connect sensors to the robot controller at a very high speed or at a high update rate. So in milliseconds, you can actually send commands to the robot joints and move these robots according to the trajectory that you have envisaged. And we are actually using these kind of interfaces to control the robot at joint level. And we call this a streaming interface. And if you want to translate it maybe to a consumer world, what we are offering is a kind of printer driver for a USB printer, but for robots. So we're offering a robot driver, and through that robot driver, we are able to send these instantaneous motion commands to each robot controller. So this list is not finite that you just saw. Actually, every robot that has a streaming interface that works in real time is compatible to our system. You just have to write the driver.
And of course, we have to update the camera sensors if they are not already in place, basically.
Exactly. So we have a catalog of components. We call it asset catalog. And in this asset catalog, you find a couple of cameras, you find a couple of force torque sensors. So all the things that you need, the basic ingredients you need to equip your automation solution with sensors, this is already there.
Yeah. Before we get into all the other questions, as we had China there, and it's so huge, and they are so far away from us already, and we step into that topic as well. One question to the scale. So, of course, I can understand that a big car manufacturer, for example, like Mercedes, is using this solution because it makes totally sense for them to implement in their factories. But if we're talking about the small machinery company that has like 2 or 3 CNC machines in-house, is it worth for them as well? Would you say so?
Yes. I think I want to make that point again about the pre-commissioning phase or the solution builder phase. We're not only working with the big OEMs of these CNC machines, but also with smaller ones that are just that can be put in front of any CNC machine. So with the OEMs, but also with the smaller companies that are just building automation solutions. So both are our customers from a solution building perspective. And then on the using perspective, of course, SMEs today, they represent the companies with high mix requirements. And this is exactly where we think that people can benefit from our approach. Because with the perception that we are offering, high mix is something that is naturally given. So you don't have to work with high volume, low mix clients of yours, but you can now also address like 1, 2, 3, 4, or batch size 1 production, basically.
Yeah, cool. So, I mean, we are always talking about shortage of skilled laborers, etc., and they are doing sometimes work that doesn't make sense. A robot could do much better and much faster, etc. So, but if it comes to knowledge to use it, I mean, I understood there will be an interface, but how do you help the clients to step into that topic? Don't get me wrong.
Yeah.
It's really like we're talking about this fancy AI all the time and the solutions, and my perspective is, the people have so much skepticism, and I think mainly it's based on being afraid of doing something wrong. So how easy it to step into that process?
I think that's something that we really want to facilitate. First of all, for the solution builder to make it much, much simpler to actually use this modern AI technology. And then for the end customer, this is not to whom we are addressing. So we are business to business, so we are talking to the solution builder. And the solution builder still provide their HMI that makes it natural to interact with the system, their end customer, so to say. And whatever can be done on that HMI to make it easier to upload the CAD data or to, let's say, reconfigure the system, that's something that the solution builder will have to do. So they are still having a unique selling proposition in that they are having their unique interface, but still based and on the technology underneath of our platform.
Yeah, to take the analogy to the smartphones, because you mentioned Android as a potential partner we get data from as well. So it could be either Samsung with One UI compared to Pixel with a pure Android feeling, etc. So they create their unique USB-based HMI that they deliver, and so you deliver the background, and this is how it works.
Exactly. So we're delivering the OS underneath, and we are not delivering any robots.
Yeah.
That's not our business, that's not our expertise.
Fully understand.
And we're also not the domain experts. So it's really important to understand that we need domain experts to, of course, serve their clients.
Yeah.
But we are just trying to help with the AI technology underneath.
Yeah. So once I'm entering this whole topic, if I understood you correctly, so basically I have the automated robot, I install the system, I have my HMI from my supplier that delivered the robot to me. So now I get a new order, I have a new part, and I build up a new process. So what do? I show the robot the part and tell him, hey, this is the way, and look yourself, basically. Look yourself.
We are not showing the real part, but we are showing a CAD model of that part. And once you have, let's say, shown that CAD model, we can immediately work with it. We can adapt the path, we can adapt the grasping points. Maybe I can show one more video to make it maybe a little bit better understandable, if that's okay. So can
Absolutely. Can we pick up the presentation again?
Maybe just to explain one more time what we are actually building. So we, as Intrinsic, we are building the solution builder tooling. So the solution builder can use this tool. There's a digital twin, there's a process tree. And this process tree is the solution in the end that is running. For the end customer, they are just working with a real cell and an HMI. This is now just an example. And if I run the video, you will see these components again. This is not a CNC machine tending case, it's an inspection use case. So what the robot is doing, it's inspecting this car body on 14 positions. So these 14 positions have been defined around that car body. Here you see how the program is actually running. In the top right corner, you see from the inspection if the car body was inspected correctly or not. Now look at the car body. The car body is moved in a different position. The digital twin is updated immediately once it has been recognized, and relative to this digital twin, the path is again computed automatically. So again, to these 14 positions, and then you see in the user interface what are the defects, bubbles, markers, or scratches. And actually this HMI in the top, this also allows you to click on the individual line and then get a picture of the defect. That is now not shown in the video. I hope it makes it a little bit clearer what we are building, the solution tooling, and what an end customer can actually do with it.
Perfect.
And the collision-free path planning is really essential here. If you do this kind of update in the classical way with a base transformation, how you do it today, you will very likely run into singularities or joint limits doing this. And because we are doing the path planning on the fly, we never run into singularities or any joint angle constraints. And I think this is important to understand for the experts in the audience.
Yeah, absolutely, absolutely. Coming back to the non-expert here on stage. Before we answer the question of the audience, let's talk. I mean, this is very good to see how it works indeed. What kind of companies are using it already today? That would be super interesting for me. What are the use cases that already exist?
So different use cases. I mean, you saw Trump. With Trump, we are doing bending and sorting. Then we have smaller CNC automation cell manufacturers, Trinity and Martin Systems. So that's in the CNC area, but there's also inspection, as you saw. For inspection, there's a prominent company, Zeiss, we can publicly mention, and Zeiss has a spin-off called Houston, with which we are operating. And actually, this company, Houston, has a business model. I think we also want to talk about that. So they come from a project-based business. So they are selling projects to car manufacturers, always snowflakes, bespoke installations. And with our software, we are kind of enabling them to go from a project-based business to a product business. So now they can build a work cell that actually can be used for inspection. And with this product business, they come into a completely different range of their business.
Yeah, and they are no longer dependent on what the client wants to do because they're fully flexible in creating their own product.
Yep.
Crazy, yeah. So is there I think I've read that a car manufacturer is using it already. Are there ones that you can mention or?
No.
No. Okay, good to know that because we just had the VDA here, so it was super interesting to know that. So we have some questions before we come back to our generic question. Let's go into that. So there's which buying options does Intrinsic offer? Purchase, subscribe, pay per use. I mean, you are selling to solution provider, not to the end user, right?
Yeah, that's also something we would like to change from a capex model to an opex model. So we have a subscription-based approach. The solution builder would buy from us a subscription for the developer seat and for the operating subscription for the robot itself. So that's a runtime fee and an operating fee and a developer fee. And the end customer in the end is paying the solution builder. So we are not owning the end customer relationship. That stays with the solution builder. And then the solution builder can do with them whatever they like. They can still sell CapEx, but of course we would recommend to turn this also into an OpEx-based model. And that's something where we try to also enable now solution builders to change their business from pure CapEx to an OpEx model or to a combined business. It's a change in the industry, and I know how difficult this is. So, but we would like to go that way.
And probably accelerate and then flatten the curve.
Flatten the curve and really bring a new mindset into the business that you have to keep your systems up to date. Otherwise, it will lose its competitive edge after 1 or 2 years. Just imagine how much this kind of AI has accelerated in the past 2 years. I would have never expected myself. So I was working like 19 years for KUKA, and I've never seen this kind of acceleration happening towards automation with the help of AI. And if you now sell a system that is not updatable, it will be outdated in 1 or 2 years.
That's crazy. I mean, as you work for a Google company or an Alphabet company, you have to answer probably this question because there's one. How dependent is the platform on US technology? And I think this goes in regards to data protection, etc.
That's a totally fair question. So first of all, when we were founded, we were coming out of, it's called Google X. That's the kind of incubator of Alphabet. So in July 21, we became an independent company, and we were founded in 2 locations, in Mountain View, that's the headquarters of Google, and in Munich, or Hamburg is our registered seat, but you have the office in Munich. It was the first time for Alphabet to actually really found the companies in 2 locations. And I think this is actually combining the best of the both worlds. So you have the robotics and Industry 4.0 expertise here in Munich, and the kind of software design, SDK expertise in Mountain View. And it's only possible to put together these 2 strengths globally to actually try to pull off something that we might call Android of robotics in the future. So this is something that can only happen when you combine the strengths of both sides of the Atlantic.
Very good, very good. So that's a good one, in my opinion. What's the usual turnaround time and resources needed from normal TP program to a ready-to-use and implemented solution? So once I say I want to do this, how long does it take?
I'm not sure if I really got the question. Is it also written here?
Yeah, we have to scroll up a little bit. Can we? No, we cannot. I have it here. I put it.
Say again.
So where is it now?
TP program, teach pendant?
Wait a sec. It's gone, sorry. So as far as I understood is, like, if you have your nowadays programming and you want to switch to the solution of Intrinsic, how long does it take to learn it and to transfer it into the new scenario?
So what I can give one good reference. The video that you just saw for the inspection solution, that was something that the company Zotek did. Zotek is a software engineering, software service provider company. They have no idea about robotics. And what they did from Christmas to the 6th of January was the basic concept of this very video and solution that you just saw. Just in a couple of days over the holiday period. And after that, of course, they matured the system and they showed it for the first time at Hannover Fair in April. So this gives you a kind of idea. So from first idea to simulation, this goes rapidly in a couple of days. When you then want to implement it in a robot cell and want to, let's say, mature it more and have an HMI, of course, it takes a couple of weeks. But it doesn't take you a year or so to really come from the idea to a productized solution.
As we are in Germany, I need to ask the following question. That's another good one, in order to cover all the technical aspects as well. Here's one that's about safety. Let me check that. Where's it gone? Here. How can we prove to customers that programming generated by AI is compliant with safety requirements? And that makes totally sense to other questions, because you say, hey, guys, you don't need the classical programming where you need to define every single movement point. Yeah. No, you say AI do it. And as we could see in the video, that was really, really amazing that you said the automated way, the pathway that you automatically create. So how can we ensure, in terms of regulation, that is safety fills out the safety requirements?
Of course, in the end, the solution builder has a responsibility to create that CE mark for a specific cell and also to make sure that there's the safety integrated. Safety today is done with the robot controller itself or with a safe PLC, very traditional technology. You have your laser scanners, you have your fences. We are not touching that at all. So that means the system safety is done in a way it has been done forever. The only thing that we simplify is the programming of the motions of the robot, be it sensor-based.
So there's still responsibility.
Yes.
Let's talk about the business aspect. I mean, comparing European manufacturing with Chinese manufacturing. For example, I just heard last year in a fair, there's a Xiaomi factory that is working without any employees. So this might be the future, with always dark, no energy cost in terms of light. That was amazing. So if we compare Europe to Asia, how critical is this automation that you push for European manufacturing to keep up?
I think it's ultimately critical, because in China, China has by far the most automation today, the most robot manufacturers, most robots deployed in production, and they are developing today and working on that dark factory. So it's not something that they are really now copying from us, but it's actually we look at them on how we can improve. So if we really have to keep up with the technology, and AI can really help us to accelerate also in the adoption of robotics. And if we not embrace it, others will. And I don't know how much manufacturing we will still keep in Europe. I really think we have to look beyond the traditional way of automation to keep up with China and then the rest of the world.
Yeah. So there's a good one here. Is the idea that anyone in a factory without robotics expertise can configure a robot in the future?
Again, we have these two phases, these two separate phases. The solution builder of this world, we make it simpler for them to create robot solutions, but you need still to be an expert to do that. For the end customer, I believe it will become much, much simpler to configure a robot system, because you don't need to have the various parameters configured, because much more is taken over by the perception system, by collision-free path planning. So this variability that you have as a solution builder translate to a good part also to the end user. It makes it easier for them.
Okay, good turn. So then we have the Trump example with the metal sorting. compared to a human being doing that, what are the advantages? Or let's talk a little bit about the use case here. How do you get together? I
Yeah.
mean, there must be an idea. How did this work out? And what is really the breakthrough here?
Actually, Trump is also one of the pioneers and leading companies when it comes to innovating in the metal sheet works with the laser technology and so on. And they keep constantly pushing the innovative edge. And at one point of time, they said, we are not the experts in robotics and AI. We have to team up with someone. And that is only the offer of collaboration that we can bring to a company like Trump and help them to innovate in areas where they are not the experts. So this is how they'll say the collaboration came about. And then, of course, Trump has this vision to also have a factory that is completely dark and that where you can automate the machines with the help of AI. And I think it's simply a perfect match right now.
Very good, very good. So let me check if there are new questions here. Oh, that's interesting. That's probably a question that only you can answer. I can't not. So how do Gemini robotics and Intrinsic relate to one another? Is there a relation?
We
work
of course,
together?
there's a relationship to Google DeepMind. We are using Google DeepMind technology to bring it in production. Gemini robotics itself is not part of our system offering, but we are testing, experimenting with it like anyone else. So if I want to compare it, maybe we are really focusing on using AI in a very focused sense and not in a very broad sense. So we never would come to the idea to learn to get from pixels to talk. Because we have already good kinematic models of our robots, so we don't need this kind of very broad approach to learn how to grasp objects. We can do a more mathematical or established approach. If I may show, because of Gemini and DeepMind,
Yeah,
if I can show one more video, that would be interesting, that you see what we are doing with DeepMind. Actually, can we switch back to the presentation screen? So this is something where we are working with Google DeepMind on a multi-robot path planning technology. This is a technology that today is also quite complicated and time-consuming for offline programmers to develop a collision-free path for multiple robots that are, for instance, doing here. This is simulating kind of spot welding on a car body. So this path here is completely auto-generated. It's based on a technology that we call Alpha Ballet. It was also just featured on Science Robotics, so it's also part of our R&D work. And that Alpha Ballet is very close to Alpha Fold. That's the technology from DeepMind where they predict how proteins are actually folding in space. So that's a very similar technology we're using here. And this kind of technology can now be used to engineer or to drastically reduce the engineering time of these multi-robot cells. You see here an example, 8 robots manually programmed. This takes hundreds of hours to do this collision-free. With our algorithm, we can do the whole programming in 1 hour and even get 24% more efficient in the execution of the path. So this is a huge win for any car manufacturer we are talking to. They really like this kind of technology. It's still in the R&D domain, but it shows the direction in which AI can bring future production.
Let us quickly talk about this one. This is a very fantastic one. So for somebody that is not an expert, I mean, we have 8 robots working together. How do they, so is it done in a model? So you tell the system, look, those are 8 robots, but do you need to tell them they are located this way, or do you just, again, put in the drawing and...
The input for everything that we do is a digital twin. So we need an accurate model of the representation of the world. So we need to know where the robots are being placed, but that's also a thing that can be done future by AI, to where to place the robot optimally.
In order to optimize it,
but in this case, it's a digital twin of the cell. And of course, we need a list of points that have to be welded or where some process has to take place. So that list has to be provided, and the rest is the algorithm.
On the other hand, you said automotive...
I think your mic is off. Your mic is off?
Oh, that's okay. That never happened before. Let me get a new one. Don't forget my question, don't be worried.
No. I can switch maybe to the next slide if you're currently out of business. Yes, now I'm losing my speaker here as well. So that's something what I also mentioned before. We are also AI model agnostic. So what you can do, you can upload, let's say, an AI model that is here used for grasp planning. And this happens to be now an NVIDIA model for grasp planning. So what you need to identify is, once you have identified the sheet metal that you want to grasp, how you can place the gripper on that sheet metal. You don't want to program this manually anymore. You also want to do it automatically. So what NVIDIA did, they trained a foundation model to actually compute automatically the grasp, the ideal grasp position on any kind of sheet metal. So why is that important? You see these holes. Of course, you don't want with your suction cups to go to the holes, because otherwise you cannot grasp the object. So you have to identify for a 3-finger gripper or for 2-finger gripper, where is the best position for this to be grasped. And then you can, of course, also use this in production. So that video is not running. Anyhow, just take this as an example.
Let's get quickly back to the car manufacturer
Yes.
quickly with the 8 robots. And you said they're doing it in 1 hour. Is that really interesting? I know there are hundreds of hours, that's cost saving, but on the other side, it's a serial production and it runs, I don't know, for years, basically, okay?
Yes.
So this is the first one. Of course, the saving is each time, but anyway, it's running for years. On the other side, what I see really, really interesting, if you're a small batch producer and you're using robots, then it's like minutes between changing products, right?
Exactly. That is what is enabling high mix. That is what is enabling high mix in the end for these small batch size production. But here it's a significant engineering effort and time. Today it takes 2 to 3 years to engineer a production line for automobiles. And one significant part is the body in white, where you actually have to weld the car bodies, the parts of the car bodies together. And if you can save on engineering time, that is something that is really appreciated by the automotive OEMs.
In between, let me ask you a personal question, because you said once in this conversation, you have been 19 years with KUKA, is that correct? So I imagine 19 years with KUKA, okay, the leading company for roboters, basically, yeah. So you're doing this all the time the classic way. How was it like? Because this is something we all experience now, you know? So you talk to a solution provider now and he steps into that topic. I mean, he might have some knowledge up front to AI. It's not that brand new, but anyway, how was it for you to do the shift? It's a very personal question,
yes,
I know, but
I have no problems to speak about
it must
that.
be like a miracle.
Yeah, so at KUKA I was heading the corporate research department. So we were already working with this kind of technology, automatic path planning, etc. But there was never really a way to offer it, let's say, in an agnostic way.
Yeah.
Because in a way I was, of course, also for KUKA and I had to work for KUKA. But my vision was always there has to be a way to bring it to a much broader audience. And then Intrinsic was offering this kind of possibility to bring it to many, many more customers across the ecosystem. And because I love to collaborate, I love to create this kind of ecosystem, that was for me a relatively easy step to say, okay, 5 years ago now, I go to Intrinsic, at that time still at Google X.
Great. So it was exciting, wasn't it?
Most exciting. Still exciting.
Still exciting. The funny thing is, yesterday we had Professor Glauner here talking about AI in general, and he mentioned once that he hasn't seen the big breakthrough. I mean, at least if we stay in the specific topic of robotics, I must disagree at this point, because this is really groundbreaking. Let's see in the question of the audience. Is Intrinsic available and supported in North America? I guess yes.
Yes.
Should be.
So we have our headquarters, as I said, is in Mountain View, California. We are in Munich and 2 offices in Toronto and Zurich. And there's also 1 larger office in Singapore. So you can also expect 24/7 support now globally from our company.
Is there any robotic provider that doesn't work or doesn't want to work with your solution, that said they go with another, let's say, stream? Is there like a competitor?
In a way,
for yours.
No. I would rather like to talk about partnering with these companies, because we have a different approach on how we want to program robots. And there's definitely a market for this, but there's also still a market for, let's say, the traditional way of automation. So when you really talk about high volume, there might be still a reason to go with a classical way. Why not? And that is something that we are not targeting at the moment. We are going really for the high mix scenarios, and we believe that with our tooling, it is easier to do that. And some of our customers also believe it's easier to do it with our tooling. So from a robot OEM or from any asset builder perspective, I think it's a good idea to be available on our platform.
Yeah.
So that they can be used for solutions by the solution builders.
So comparing it to with, for example, Gemini, so the more consumer-focused AI things, what is the business model for the future? Will it stay like a subscription-based model that is you can have basically licenses for each robot, or is there idea of changing the business model to another?
I think what we are doing now is actually changing the business models of many, that we actually want to have this kind of subscription-based model, because subscription in the end allows you to offer services that today you do not offer. So even a system integrator today is not keeping the customer relationship after they have actually sold their system. Only a few of them go to maintenance contracts. And we would like to help these solution builders to change the way they can think about their business.
Yeah.
It's a change now first in this direction with the subscription model, and I don't know what comes after that.
Okay. So let's get back to the 10% in Europe. What are the next steps we are doing here together? I mean, we are at the EMO.
Yes.
We have probably the end users. We have them here. So how do we support them to bring up the speed to the industry and speed up so that we're talking about, let's say it, 30%?
I mean, I think that's why I'm also here during this week, also with two colleagues. So we are reaching out to the solution builders that are present here and informing them how we would like to collaborate with them. It's not really publicly known. Of course, we have a website and you can see what we are doing, but the product and the services that we are offering still require some explanation. And that is where we are doing now a first outreach here at the exhibition and see who of the solution builders are really interested in something like we are offering. And then it's more a partnership in the beginning, because our product is not generally available. We are only working with partners like Trump, for instance, or Martin Systems or Trinity Automation in this space to build products with them.
If you say China is far ahead, does that mean that you have already running projects in China, or is that something that China does?
Right now we are focusing on Europe and North America.
Okay, good to know. Then the question here would be, let me get back to one of the questions of the audience. That's a good one. What is the most common trigger on the customer side that causes them to reach out to you?
I think there can be many triggers actually. So one trigger could be, maybe you can also switch back to the QR code that maybe other questions can come up. Just don't have to show this all the time. I think the trigger can be on infrastructure. So a company doesn't really want to invest into infrastructure anymore. So the glue kit or the plumbing that is required to build a solution, and they can simply take our infrastructure and build on top of that. So for the higher value algorithms and applications they are building, and just take the infrastructure piece by us. A second reason can be, of course, the capabilities that we are offering. So there's not too many companies out there that are offering this kind of robotics and AI capabilities. And maybe a third reason, I think also that the tooling that we are offering is rather simple to use. It's a service-based architecture, so anyone with decent software skills can actually get very fast into this programming.
One thing that I want to ask you, because we had many innovations here on stage that presented an AI-based solution, and many of them I would see related to yours. May it be cameras, and we talked about the sensors. So is it only talking to the solution provider, or is it also getting to a bigger network? Don't get me wrong, but
no, it's true.
Let's see, if we want to revolutionize that and get the most out of it, why just start with purely the robot, because the environment that you need in order to reach like the metal part detection and the visuals, is that something that already happens, and
Maybe.
in what scale?
Yeah, maybe answer the first part of the question also because I witnessed it myself coming from KUKA to Intrinsic. When you're a startup, you really have to focus. And if you think you have already focused a lot and you have this thin slice with which you're going to the market, it can be even thinner. So you really have to focus what you're doing, and that's why we are now only focusing, let's say, on CNC manufacturing, inspection, metal sheet processes, so really working with industrial robots. And what was the second part of the question?
The second, is like all the environment that is
Yes,
needed.
and then the asset builders today, you always need like two experts to build one solution. You need the perception expert on, let's say, on any camera manufacturer. Now I'm, let's say, Basler, Keyence, whatever. So they need an expert to do image processing, and you need the robotics experts. And what we are trying to do is we are merging or collapsing this into one person that can actually do both, because it's easily integrated and configurable in one tool.
Oh, there's a very critical one, and this might turn to the end of our session. Very good that we come into conclusion finding again. It's unclear what the AI innovation is. It looks more like a machine learning application.
I mean, first of all, it's difficult to define AI. Machine learning is like one level, then there's deep learning, reinforcement learning. I tried to explain it before, foundation models, large language models. There's a couple of different AI technologies, and I think it's really difficult for everyone to really grasp what that all means. And we are trying to really simplify the access to all these various technologies in the different domains where you can use it for a robot system, be it sensor-guided insertion, be it perceiving an object and then handling it. Once you see AI, it's not any longer exciting. Once it's realized in products, it's not any longer exciting. But we are now at this stage where we're bringing it into products.
Very good. So let's take a look into the future. Let's do that a little bit, because I would be interested in what are the next steps. You're talking to solution providers, but now the question would be too hard to ask how it will be ending, because that's totally stupid, because hopefully there will no end. When do we see this kind of automation? What do you think? What is your estimation in years? Like,
I have been proved wrong many times in my career when I was trying to answer questions like when will service robots be available. It's really difficult to tell, because we are now at this cusp where we believe that AI is getting into this exponential curve. We can see this already today in the consumer business, and for business to business or the industry, it's not yet happening. So once we have reached that inflection point, it will massively take off.
Yeah. So that's very...
I'm because let's say in 1, 2, 3 years latest, I would estimate that many more systems will use this kind of AI technology. It's not too far in the future.
Very good. So one last technical question. Sorry, I haven't asked it before, but I was super interested because you showed the video. You have the metal detection, okay? Mm-hmm. So as I understood, you can put whatever part you want to put in, and it will detect it. And how does the system learns it? I mean, it could be different material, could be a different part, could be different weight. Mm-hmm. And to learn the weight, for example, it's not only about visuals, you need to lift it up, right?
But this is what you actually get with the CAD data with which you are prompting. Yeah. This CAD data can also contain the component. This is the mass of the object you want to handle. But your question about how this is being trained is very interesting, because what you do is you take the CAD model and you generate 1 million of artificial images that look at this CAD model from various angles with various backgrounds. It's a really interesting technology, and then you have a deep learning approach where you know where this part has been placed in the scene, despite all these very interesting artificial backgrounds, and you're able to recognize it. And because we are learning it in very artificial backgrounds, reflections, metal shining, glass, transparent objects, this can be all recognized now. It's really easy. And maybe we are training these foundation models on 100,000 parts, and then we have a good foundation for 3D parts. Yeah.
Awesome. I really enjoyed it, Rainer, really. We're coming to the end of the session. Let me excuse if I ask too many no expert question, but it's such a fascinating topic, and it's really much into what I expect from the future of factories. So it was super exciting to have you here. Thank you so much, and good luck for your talks here at EMO. Hope to speed up very soon and very fast, because this is what we need, in my opinion, in my regards. So thank you very much, Dr. Rainer Bischoff. Big applause, ladies and gentlemen.
Thank you for your interest and all your questions. Yeah?